I'm going over the keys so that you can render a grade for your derivative quiz and self-support it. You may want to pause as you go along. I don't know. We'll see how it goes. I will try to give you a rubric on each problem as well. My primary objective is for teaching and learning to continue unabated, and assessment is actually a secondary objective in my mind. But I do have plans A and B. Plan A is if we come back and I give you tests in the testing center. And plan B is something that will happen if we don't come back. That's not my preference, but if that happens, I am prepared. More about that later. But in either case, grades are earned and will be rendered, and goals can remain intact. So this quiz counts if I get your feedback, otherwise it's a 0. You should think there are 10 points per numbered problem, and divide the total earned by 150 to get a percentage. Okay, so number 1 says y is equal to this function. You're to evaluate the derivative at x equal 13. The complete answer is 0. The derivative should end up being what you see in the middle. If the derivative is wrong, it's minus 10. If the number is wrong, but the derivative is right, it is minus 2. Here's number 2. This is the quotient rule. So when you do this, you should get a derivative that shows as I have it here. If you miss anything, it is minus 10 on the derivative, but then you should observe that the derivative does not exist at x equal minus 1. That last thing was worth 2 points if you're making that observation. Number 3, we had this. You had to use the product rule, chain rule, and constant rule, I guess. You're evaluating it at f prime at minus pi over 12. So the derivative, you can see here, the derivative has to be 100% right, or else it's minus 10, the way I would grade it. And the number that you come up with is this number that you see. Some students would say that's the ugliest damn number I've ever seen in my life, but there are no ugly numbers. So that's what I do expect you to get. If you had it formatted differently, but exactly the same number, that's fine. So again, the derivative is 8 points, and minus 10 if you didn't get the derivative right, and then the number is worth 2 points, or minus 2 if you got the number wrong. Number 4 is an implicit differentiation problem, and the answer is minus pi over 3. Again, minus 10 if you didn't do the derivative right, and minus 2 if you screwed up the number calculation. Number 5, this is the product rule with different functions. There's the derivative, that's minus 10 if you didn't get that completely right in my rubric. If you put the numbers in, you get 3. Number 6 is the quotient rule with logarithms and so on and so forth. So you had to get the derivative stated correctly. That is minus 10 if you didn't get that. You plug in the numbers and you get 1 minus 3 ln of 2. There's different ways you can write that, but that is the answer that you needed to have. Number 7, I ask you to use the limit definition to find f prime of minus 1 for that function. If you did just use the formulas, you should count yourself minus 10. I expect you to start the problem off the way I've written it here, and go through a whole bunch of calculations, algebra, taking the limits, and so on and so forth, and conclude with minus 1. So I guess minus 10 if you didn't do the problem this way. It's 10 if you did the problem, got that, and if you screwed up along the way but had the initial statement right, I guess that would be probably like a minus 5. Problem 8 is the chain rule. It's the chain rule several deep. So if you got the derivative wrong, it's minus 10. Let's do minus 2 for the slope and the y-intercept in the line I ask you for. Number 9, again, was implicit differentiation. Count each thing 3 points, so the answer should have been 7, 7, and 2, and those are worth 3 points. If you did something correct, you can give yourself 1 point other than that, but 3 points for each one of those adds up to 10. Number 10 is a related rates problem. You had to draw a picture. Here's the picture that you want to draw. Use Pythagorean theorem, take the derivative, and you get minus 94 over 13. If you didn't make a dent in the problem, it would be minus 10. Working the problem, getting the correct answer is plus 10. And if you think you did something worthwhile along the way, maybe call it 5. Number 11, every point on the graph has coordinates x0, x0 to the 5th plus 4x0 minus 3. So I guess really I'll just say this. The answer to the problem should have been minus 1 comma minus 8. Those are each worth 4 points, and you can give yourself 2 points if you did something else that you thought was useful along the way. Number 12 is velocity, acceleration, so on and so forth. There are 5 parts. Each is worth 2. 1 point for the unit and 1 point for the number, I guess. So it should be minus 20 feet for A. Let's see, B is minus 27 over 2 feet per second. Of course, you could have that minus 13.5 feet per second. And I just observe the particles going left. The acceleration when t is equal to 1 is going to be positive 6 feet per second squared. When does the particle change direction? It changes direction at t equal to. And number E, the answer is 31 feet. So, you know, those are kind of right or wrong, 2 points, so on and so forth. Problem 13. We were supposed to, without graphing, show this function has exactly 1 real root. So it's a continuous function that is negative at x equal minus 5 and positive at x equal minus 2. So by the intermediate value theorem, there's at least 1 root between these two values. When you consider the derivative, it's increasing if it's less than minus 2 and decreasing only from minus 2 to 0 and increasing thereafter. But it reaches 20 at minus 2 and only drops to 16 at 0. Therefore, the only root that we can have is the one that the intermediate value theorem is telling us about. And if we do analysis of potential integer roots like you studied in your pre-calculus, you can conclude that x equal minus 4 is the root. Count each of those worth 4 points and give you 2 points if you did something that you thought was worthwhile otherwise. Number 14, you were supposed to sketch one continuous function on this possessing all the properties. Okay, first of all, it had to be a function. If you don't have a function, if it doesn't pass the vertical line test, it's wrong. It has to be defined at every point from minus 10 to 10. If you didn't do that, it's wrong. It has to be decreasing at minus 5, but the y-coordinate at minus 5 has to be positive. It must be increasing at 5, and the y-coordinate at 5 has to be negative. You have to have an abrupt change of direction at 3 because the derivative doesn't exist. You have to have at minus 7 and at 6 you have to have relative maxima or minima because the derivative is equal to 0. It has to be concave up. At minus 7 it is, and it has to be concave down at 6, and my example is. Your example could be different, but all those things have to be there. Subtract off 1 for everything you missed. Okay, and here again, 15, what's the minimum number of zeros that your function must have? So since the function is continuous on a closed interval, we know from the intermediate value property that there is a zero between -5 and 5 because they are opposite in sign. So there's at least one. There could be more. My example had 4.